Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning, everyone. Today we will examine two foundational early photography techniques, the Daguerreotype and the Calotype, and why each mattered to the development of photographic practice in the 19th century. I will first describe the Daguerreotype process. Invented by Louis Daguerre and publicly announced in 1839, this process produced a single, highly detailed image on a silver-plated copper plate. The metal surface had to be polished to a mirror finish, then sensitized by exposing it to iodine vapors, which formed a layer of silver iodide on the surface. After exposure in the camera, the latent image was developed with warm mercury vapor. The mercury combined with the exposed silver halide to form a visible image. The picture was then fixed using a solution such as sodium thiosulfate to remove remaining light-sensitive salts. Because the image was formed directly on the metal plate, there was no negative and no direct way to make multiple copies. Each daguerreotype was a unique object, and it was often sealed under glass and presented in a case for protection. These images were prized for their sharpness and fine detail. A classic example of the daguerreotype is Daguerre's Boulevard du Temple from Paris. This early city scene is famous because the long exposure time meant most moving figures did not register. However, one stationary figure and a shoeshine man appeared. Their presence demonstrates both the long exposures that were necessary and the capacity for surprising detail. Now I will contrast the Calotype developed by William Henry Fox Talbot and patented in the early 1840s. The Calotype introduced the idea of a paper negative, allowing multiple positive prints for the Calotype. Talbot coated high-quality writing paper with silver nitrate and potassium iodide to form silver iodide. He then treated the paper with a solution that included gallic acid and additional silver nitrate to sensitize and develop the latent image. The result was a paper negative that could be placed in contact with another sheet of sensitized paper and exposed to sunlight to create a positive print. Talbot's latticed window at Lecoq Abbey is a well-known Calotype and illustrates the softer tonal quality that paper negatives produced compared with metal plates. Technically, there were trade-offs between the two methods. The daguerreotype offered unmatched surface detail because of the reflective metal base and the fine grain of the silver image. The Calotype, on the other hand, allowed reproducibility because the paper negative produced multiple positives. The texture of paper fibers meant Calotypes often had a softer, more textured appearance. Exposure times differed as well. Early daguerreotypes required shorter exposures than the earliest paper processes because the polished metal and chemical sensitivity delivered more rapid capture under the same lighting conditions. But both methods initially demanded long exposures compared to later techniques, and this affected the kinds of subjects that could be successfully photographed. Practical applications influenced the adoption of each method. Portrait studios favored daguerreotypes for clients who wanted extremely sharp and detailed likenesses. The Calotype found use in situations where scientists, architects, and publishers needed multiple copies for study and distribution. For example, early scientific documentation and topographic surveys benefited from having reproducible negatives. There were also economic and legal factors. Talbot's patent on the Calotype slowed its adoption in Britain because landscape photographers and publishers faced licensing fees. The Daguerreotype was promoted by the French government, which released the process to the public, and that helped its rapid spread in continental Europe. We should also consider health and handling issues. Mercury vapor used in developing daguerreotypes posed real hazards. The highly polished metal surfaces were delicate and required careful sealing. Calotype prints and negatives needed protection from moisture and abrasion, but were easier to reproduce and distribute. The Calotype introduced the idea of a paper negative, allowing multiple positive prints, a groundbreaking change in reproducibility. In summary, both techniques made distinct contributions. The Daguerreotype demonstrated an ability to capture fine detail and created beautiful, one-of-a-kind images. The Calotype introduced the negative-positive workflow that underpins most photographic processes that followed and enabled reproducible imagery. Both remain crucial to understanding early photographic practice.
Listen again to part of the lecture, then answer the question.
The Calotype introduced the idea of a paper negative, allowing multiple positive prints, a groundbreaking change in reproducibility.
This concludes the listening section. For more TOEFL practice tests and study materials, visit Spinta.org.